Good afternoon, period 7. Welcome back, guys. Here we go. Let's begin a brand new unit of study with rational expressions. Here's the title for today's notes. We have dividing rational expressions. So in this month of March, we should be prepared to see many rational expressions. What exactly is a rational expression? Well, look, it has the word ratio. Ratio is a comparison. It's like a fraction. This month, lots of fractions all day, every day. So here's the definition. You guys can put this down on your papers if you would. So in this month of March, it's going to be rational expressions, where we have basically a bunch of fractions. And what can we do with fractions? Well, we can add them, subtract them, divide them, multiply them. We can solve equations with them. And that's what we'll be doing this month. Today, day number 1, we'll keep it simple. It's day 1. It's just introduction type of stuff. And I think the easiest thing to do with fractions is actually to multiply them and to divide them. That actually is easier than adding and subtracting. So that'd be a good thing to do for day 1. And that's what we'll do today. We'll just be taking a couple of fractions and dividing them and multiplying them. We'll see. So here's the definition. And I'd like to try 3 problems with you this afternoon. So let's take a look at the first one here, shall we? So that's just definition. There it is. So problem number 1 is right here. And let's give this a go. Let's do this problem like the traditional long way, and then I'll give you some comments or some advice as to how to do this much faster. So we want to divide. So let's take 30/14 and we're going to have to divide it by this fraction here. Now, in reality, we're not trying to divide fractions. We prefer to multiply them. So what you do, and I'm sure you've seen this before, equals equals. What you do, instead of division, write down the fractions again, but this time from division, turn it into multiplication. And the first fraction stays the same. The one on the left stays. It's the one on the right that gets flipped. The proper word is reciprocated, right? You turn this second fraction upside down. That's just the mechanics behind, that's just what we do, right? From division to multiplication, keep the left, flip the right. Now, here is sort of the traditional way of doing this. Let's write down some new fractions. So what you do is you look at all of the numbers. You look here, you look there, you look at all of these. And you think about what would be the best thing to do. When I see 30 and let's say 130, I'm thinking of this. I'm thinking of taking 30 and turning it into 3 times 10. And I'm thinking of taking 130 and going 13 times 10. The reason I did that is because in just a moment, that 10 is going to knock out that 10. That's why I did what I did, because I saw that this number and this number had a 10 in common. What about the other numbers? This one here, that one there. Well, 14, I'll probably leave it the same because this may sound weird, but I actually know that 14 goes into this number. And it's just, you do math long enough, you see patterns. So look, 154 is actually 14 times 11. And so that's why I did what I did with these numbers, because I saw that once I did this with this pink marker, this 10 in the top can knock out this 10 in the bottom, right? That 14 here, it knocks out that 14 there. It doesn't matter if they're across. They could be across or directly above or below one another. What matters most is that one is in the top and one is in the bottom, which is why the 14's knocked out and the 10's knocked out. So what exactly is left? What are we left with? In the top left, we're left with a 3. In the bottom left, there is nothing there. It's just a 1. Up here is 11, and down here is 13. Do you see anything else that can sort of knock out? I don't. So really, we're finished. And there should be one fraction for the final answer. So we have to actually finally multiply them. And so we go 3 times 11 and 1 times 13. And this is the final result. So this is like the traditional way of doing it. But on an exam or on your homework, what should you do? Bro, just type it in. Just type this in here and go straight from question to answer. So how come we did it like that? We did this the long way to establish a routine. How that instead of dividing fractions, you want to multiply. And once you have it set, you look at all the pieces and you think about how you can factor or break them down into smaller pieces so that stuff can knock out. That's why we did this the long way. But I'm telling you now, if you have just numbers, just type it in here and be done with it, okay? Let's try this one. We're doing 3 exercises. Let's see what this one has to offer. And here it says find the quotient. That's just a fancy way of saying divide. For our purposes, that basically just means divide. That's basically what that means. So let's write this down again with that being divided by that. So we have 12q to the 17th. And then we have 5p23 division 68q40 over whatever it says there. It said 35p60. And let's do that thing where instead of divide, we prefer to multiply the fractions. So I keep forgetting to write equals. Equals equals. So now let's just keep the first fraction the same, but let's flip the second fraction. So we have 12q17, 5p23, and then flip it. Reciprocate it. 35p60 over 68q40. Okay, there we are. And let's see here. What's the best way of doing an exercise like this? What if we focus just on the coefficients? Look at the 12, 5, 35, and 6. Just focus on those numbers. And as a matter of fact, we can prepare the next step right now if you want. So, 12. Do you want to interact the 12 with that one or with that one? Which one is better to play with? I'm thinking 12 should be looked at with 68. And think of a number. What's the biggest number that you can think of that goes into 12, but that also goes into 68? If you examine that thought, it should be 4, the number 4. So the number 4 goes into 12 how many times? It goes into 12 3 times. And the number 4 goes into 68 17 times. Right, so this is gone and it turns into 17. So I'll leave this blank for now. So we took the number 4 and we divided it into there and there. How about 5 and 35? What's the biggest number that goes into both of them? Well, obviously the number 5, right? 5 goes into itself once and 5 goes into that 7 times. So I think what we can do is we can write down just the coefficients. These are the numbers that have survived. And as a matter of fact, if you look at these numbers, there is no other simplification that can take place with those numbers. They're done. Now let's look at the variables. And how about we start with the letter P? And this is a competition. You have the stuff in the top versus the stuff in the bottom. Who wins? Well, let's see. Here I have 60 P's and here I have 23 P's. So obviously the top is stronger. So the top wins, and the top wins, it gets the P. But the question is, what exponent do you put here? Well, ask yourself, I know the top won, but by how many did it win? How much bigger is 60 than 23? It's a matter of subtraction. And if you subtract that, you should get 37. That's how you reduce these guys. That's how you think about these variables. It's a competition. How about the Q's? Q17 over Q40. Who wins? Well, obviously the bottom wins. So I'll put the Q's in the bottom. But by how many did it win by? 40 versus 17. 40 is bigger than that by 23. So that's 23. Equals. Now, guys, I think we're finished. I think now we're ready to just write down the final answer because nothing else goes away. So in the top, we have 3 times 7, 21, P to the 37th. And in the bottom, it's 1 times the stuff. It's just 1, right? It's 1 times that, so it's just going to stay that. 17, Q to the 23. box that in, we're done. So let's try one more here for today and then we'll be finished. So that's how we do this, right? From division to multiplication, break up the little pieces and just do what you gotta do. Simplify, knock things out. It's legit. All right, last one here for today. And your homework, I think you have to do like 2 problems or 3 problems, something like that. Your homework it comes from a textbook that was written many years ago. So I'll show you. This will just be real quick. Watch. I have some books here. I have some textbooks here that are like prehistoric. These books are ancient. Let me show you one of these. Let me focus my camera and go closer to the camera. Look at this book here. This book is like super old. If I open this book, look at these words. I mean, it looks like prehistoric. Let me go to the front. Let me show you when this was published. I'm not sure if you can see it, but it says right there, 1827. So this book is like almost 200 years old, right? Almost 200 years old. It's so cool. Anyways, your homework comes from here. There's a page in here that looks like the stuff that we're doing there on the board. And so I took a picture of a page from this old book and it looks like the stuff we're learning. So that's where your homework comes from for today, just FYI. All right, let's do this. So let's divide. So let's shut down the first fraction. Yeah, math has been around for a long time, right? Now look, if it's okay with you, we can save a couple of seconds here of work. Instead of writing the division step, I'm just gonna go straight into multiplication. But that of course implies that you have to take this fraction and turn it upside down. I think that you would all agree with me that this is what we get. If you want to be more patient than I am, if you want to write down the first step where it's just basically like that, that's totally fine. Either way, we end up here where we have to turn division to multiplication and this gets turned upside down. Okay, so equals again. Now, I'm looking at all these pieces. I'm seeing what I can simplify. When I look here, I see that I have 2 pieces. But what exactly can you take out from both pieces? What comes out of a 4 and comes out of a 12? The number 4. This has x squared. This has x. What can you take out from x squared and x? You can take out 1x. And I'm left with this on the outside. So if I take out 4x from here, what am I left with on the inside? Well, 4x removed from 4x squared leaves you with x. And then 4x divided away from 12x, you're left with positive 3. This is what we call the greatest common factor. And you know that this is legit because in your head, if you distribute that and that, this is what you get back. And that's what it would be. Let's keep the top right the same. Okay, so that's what we have so far. I'll let you catch up. Let me make sure my camera looks legit here. Okay. Now, here's the last step. These guys look the same, but they're backwards. I like this one because it's the letter first. I'm going to keep that one. But this one, nuh-uh. Watch what we can do here. I'll do it in pink. A quick timeout. You see how it says 6 minus x? Watch what we can do. 6 minus x is the same as negative x plus 6, right? You can switch the order. If I take out a negative 1, I would be left with x minus 6. There was a negative 1 right here. There was always a negative 1. And if I remove it to the front, here's what I'm left with on the inside. Because if I distribute the negative 1, I would get back the previous step. So I know for sure that all of these are equal. So instead of writing 6 minus x here, instead of that, nuh-uh, I'm going to change it. Instead of 6 minus x, I'm going to go like that. Negative 1 with an x minus 6. I'm going to go like that, right? I'm going to go from there to there, boom, boom. Now, how come I did that? Well, first of all, because it's correct. But the reason this is good is because now the x minus 6 and the x minus 6, they're gone. You see what I'm saying? So that's why we did this manipulation, so that these guys could go away. You can put parentheses there if you want to. And also, look at what happens here. X plus 3 knocks out x plus 3. And guys, we're finished. Because we can write down what's left here. In the top left, it's just negative 1. In the bottom left, it's just 4x. And in the top right, it's just 1. And there's nothing here actually. That's just one. Both of these guys got knocked out. So if you clean that up, it's just going to be -1 over 4x. So your homework is based on this idea. And I think you have to try 2 or 3 problems, I forget. But give it a go and let me know if you have any questions and I'll gladly help. So have a great day, guys, and I'll see you next week.